Alright guys, in this next video we're looking at graphs and how to graph quadratic functions. This is a really important section here. Take good notes. This is something you will definitely need in the future. So quadratic functions is anything in the form f of x equals ax squared plus bx plus c. Now remember, f of x is the same as y, and the big key to this is the squared. So anytime something has a squared in it, this is a quadratic. Okay? Now the shape of a graph that is a quadratic is a parabola. And a parabola is a U-shaped graph. Now there are certain characteristics of this parent graph, and a parent graph is the most basic of those graphs. Now the first certain characteristic is what's called the axis of symmetry. This formula here that I'm circling is one you must have in your notes. Okay? That is the axis of symmetry. You're going to use this all the time in this class. So x equals negative b over 2a, and the b and the a come from our equation up above. Now the other one that you're going to need to know is the y-intercept, and the y-intercept is the point 0c, and again c comes from this equation right up here in the first part of this. Now the domain for all quadratics, anything with a squared, is all real numbers, and that's what this symbol right here means. So this is all real numbers. The range for the parent function is y is greater than or equal to 0. Okay? Remember, domain is your x, range is your y. Now, there's a couple different things you can tell about these graphs. The first one, if your a is greater than 0, the graph opens up. Okay? So you'll have a parabola or a U-shaped graph that looks like this. If the a is less than 0, so think negatives, the graph will open down and will look like that. Now, what you've got over here on this picture is a few points. Okay, the first point is what's called the vertex. The vertex is the bottom of your U. Okay, and if you connect these dots, you'll see that they are U-shaped. The bottom of that U is called your vertex. The line that runs right down the center, up at the top here, you'll see AOS. This AOS is the axis of symmetry, and it's the line that runs right down the center of your entire parabola. And these things are perfectly reflected on opposite sides. Okay, so every point has a reflected point across that parabola. All right, so these are some of the things we're going to end up using in graphing these. So let's keep going on. So here we go. First thing says graph by plotting points. Now this is one way that you can graph parabolas. Okay, graph by plotting points. And here's what I mean by that. You're going to start by picking a number and substituting it in. Okay, so if I go with the 3x squared plus 6x plus 4. That was our function, okay, back from this first page. Let me move this down a little. Oh, sorry, minus 4. So 3x squared plus 6x minus 4. Okay, so I'm going to change that. Now, when we plot points, what that means is I'm creating essentially a table. And we've done this before with linear functions, or the ones that are lines. And you just substitute in some values. So if I say I want to plug 0 in, I take 0, substitute it in, and solve. So 3 times 0 squared, well, that equals 0. 6 times 0 is 0. So 0 plus 0 minus 4 is negative 4. And this creates a y. Now here are my x values, here are my y values, and that's a point. My first point would be 0, negative 4. Okay, and then I pick another value. So let's say 1. If I substitute 1 in, and I work it out. So going order of operations, I do 1 squared is 1, times 3 is 3. Plus 6 times 1 is 6, minus 4. So 3 plus 6 is 9, minus 4 is 5. So that gives me the point 1, 5. And I could keep going through this. So let's say I do negative 1. Okay, so I got 3 times negative 1 squared plus 6 times negative 1 minus 4. Go ahead and solve this. So negative 1 squared is 1 times 3 is 3. 6 times negative 1 is a negative 6 minus 4. So 3 minus 6 is negative 3. Negative 3 minus 4 is negative 7. So my point would be negative 1, negative 7. All right, so I've got these 3 points here. So 0, negative 4, 1, 5, and negative 1, negative 7. Now what I'm going to do is I'm going to go back to my graph and actually graph those. Okay, so go back to this first page. Move back down to where my graph's at. And I'm going to plot those points. So 0, negative 4 on my graph is right here. 1, 5 on my graph is right here, and then -1, -7 is right, oops, sorry, it's -6, -7 is right here. And what you can see is I've got 3 points, don't really know what this looks like, so it doesn't help us a whole lot. And so what you'd end up having to do is choose a bunch more points, and eventually, as you choose more and more and more points, you'll start to see that this thing will round out and become a parabola. Now, that's possible. You could do it this way, but it's not the easiest way. And what I want to show is the easiest way to do this. Alright, so we're going to be asked to find a couple things. Okay, the vertex, the axis of symmetry, and the y-intercept. Now, based on the graph that we have here, I've got this parabola. Okay, and all of these pieces of information are going to help me graph this. Well, what is your vertex? Your vertex is your lowest point. So if you look at your lowest point right there, that's your vertex. So the vertex is the point -2, -4. Axis of symmetry. Well, the axis of symmetry is the line that goes right down the middle. And this line that I'm drawing in is the line right down the middle. Okay, well, if you look, it goes through -2, so the axis of symmetry is -2. Now, it's not a coincidence that those two things are the same. They will always be the same. The vertex is x value and the axis of symmetry. And then the last thing that they're going to ask you for is the y-intercept. And the y-intercept, if you look, it's where my graph crosses the y-axis, and if I continue this graph on, it crosses at the point 0, 1. Well, what that leads me to is understanding that if I have a vertex, I have a y-intercept, those are 2 points on my graph, I can find the third point by using this axis of symmetry. Okay? And that's what we need to be able to do in this last part. Okay? So, here's what I've got. I'm going to be asked to find the vertex, axis of symmetry, and the y-intercept of an actual function. Now, here's how it works. The minimum and maximum values represent the highest points on the graph. Okay? In both cases, this is the vertex. Okay? So what we want to understand is if I find the maximum or the minimum, I am finding the vertex. Well, how's that done? We use a formula that we had up above. Okay? I told you up above that the axis of symmetry is -b over 2a. Now, what I also told you is that it's not a coincidence that that axis of symmetry and the vertex's x value are the same. So we're going to use this formula to find the vertex. Okay, so that's where you're going to head. All right, now if you think about the equation at the beginning, it was f of x equals ax squared plus bx plus c. So I have my a, b, and c right there. So here's what you're going to do. You're going to take and use our formula here to solve for this vertex. All right, so x equals -b. Well, b is 4, so -b would be -4. Over 2 times a, that gives me 2 times 2, because a is 2 from right here. All right, solving that out, I've got -4 over 4, which gives me -1. Now what this is if I'm looking for my vertex, it's the x value of a vertex. Now to find the y value, what you're going to do is you're going to take that and substitute it into your problem. So I got y equals 2 times x. Well, our x is right here from our vertex, plus 4 times x minus 3. Now solve this out. -1 squared is 1 times 2 is 2. 4 times -1 is -4, minus 3. Continue on. 2 minus 4 is -2, minus 3 is -5. Now what this is my y value of my vertex. I have now found a vertex. Okay, the second part is the axis of symmetry. Well, remember, I already told you the axis of symmetry is always the x value of your vertex, so it's -1. And then finally, my y-intercept. The y-intercept is the point 0c. And we saw that up here at the beginning right there. So your y-intercept is always the point 0c. So I look at my function. My c is -3, so I have the point 0, -3, and there you go. You've got your vertex, you've got your axis of symmetry, and you've got your y-intercept. Now, what does that let us do? What it lets us do is actually graph. Okay, so I'm going to skip this next part for a second. And we're going to graph one of these. Okay, so from start to finish, here's how you're going to do this. Get rid of this for a minute. Get rid of this for a minute. Here we go. So I've got x squared plus 4x plus 3. Remember, a, b, c. Now there's not a number in front of a, so it's technically a 1. Make sure you understand that. So I need three things. I need the vertex. I need the axis of symmetry. And I need the y-intercept. All right, here's how it's done. Vertex, use my formula. X equals negative b over 2a. So solving that out, x equals negative b. Well, b is 4, so that's negative 4. Over 2 times a is 1. I keep working, that's negative 4 over 2. Negative 4 over 2 is negative 2. So there's the first part of my vertex. For the second part, I take that negative 2 and I substitute it into my problem. So x squared is negative 2 squared plus 4 times x is 4 times negative 2 plus 3. And we solve. Okay, and again, that's this equation with that number substituted in. So negative 2 squared is 4. 4 times negative 2 is a negative 8 plus 3. So this is negative 4 plus 3, or negative 1. That is the other part of my vertex, which is negative 1. All right, axis of symmetry, like we said before, that is the x value there. So I got negative 2. And then my y-intercept is the point 0, c. If you look back over at your equation, c is 3, so I've got the point 0, 3. And finally, to finish this problem up, we graph. All right, vertex is negative 2, negative 1. So I go negative 2, negative 1, put a point. There's my vertex. My y-intercept is the point 0, 3. 0, 3 is right there. So I've got those 2 points. Vertex, y-intercept from here and here. All right, we also have the axis of symmetry. Now remember, the axis of symmetry is the point that goes right down the middle, and everything reflects across from that. So if you look at this point 0, 3, there's going to be a point directly across from this point here, the exact same distance. Well, that point is 2 away from the axis of symmetry. I go 2 more on the other side. There's my extra point. Now notice they are directly across from each other, equal distance, 3 points. There's my graph. All right, lots of work in this section. We will spend some time in class working on this and talk a little bit more about the rest of this stuff. So make sure you take good notes here. If you have to, go back and watch this again. Okay? I will answer any questions in class, but we need to make sure we get better at these basic skills.